In this module, we'll be talking about systems and system elements as they relate to the RMF in version 2.0. Let's jump into the slide deck. In this module, we'll talk about system and system elements. It's important to first define what an information system is. It's important to describe an information system in the context of the SDLC, or the System Development Lifecycle process, and how security and privacy capabilities are implemented within the components of those systems. So we want to make sure that system, security, and privacy controls are integrated throughout the information system as early as possible in the SDLC. Therefore, organizations executing the RMF take a broad view of the life cycle of the information system development to provide a contextual relationship and linkage to the architectural and engineering concepts that allow security and privacy risks, including supply chain risk, to be addressed throughout the life cycle and at the appropriate level of detail to help ensure that such capabilities are achieved. So we want to make sure that not only are system security controls and privacy controls implemented as early as possible in the SDLC, but at the appropriate time and with the appropriate level of detail at each of those stages to be effective and efficient in countering the risks to the privacy of the system or the security of the system. An engineering view of the information system and the entities with which the system interacts in its environment operation is important. This is according to ISO 15288. System security engineering should be viewed as part of the SDLC, or the System Development Lifecycle. We need to make sure that security engineering is part of the SDLC. It's integrated in the SDLC at your organization. A system is a set of interacting elements that are organized to achieve one or more stated purposes. Again, ISO 15288. An information system as a discrete set of information resources organized for the collection, processing, maintenance, use, sharing, dissemination, or disposal of information. That's from the federal law enforcement. And resources that comprise an information system include information and other resources, and system elements include technology or machine elements, human elements, and physical or environmental elements. So there's a few different definitions of system elements. These are the pieces of the system that make up the information system, the discrete pieces. So it could be a server, it could be a set of servers, it could be a process, it could be a number of things that makes up the different system elements that comprise together to make the information system. That includes, the bottom line is important here, it includes technology or machine elements, human elements, and physical or environmental elements that can be brought together to make up an information system. Each of the system requirements within the systems fulfills specified requirements and may be implemented via hardware, software, or firmware physical structures or devices, or people, processes, policies, and procedures. So we can see it's not only the information system as we think about it in the classical sense, but it's also people, processes, policies, and procedures that make up the information systems. And you'll see that when we go to develop controls, implement controls, and assess controls. They're not all technical. Some of them are related to policies, procedures, and other things beyond just the technical requirements. Individual system elements or a combination of system elements may satisfy stated system requirements. Interconnections between system elements allow those elements to interact as necessary to produce a capability as specified by the system requirements. So we start out defining a system requirement, and then we build the system to meet that requirement. And sometimes there's multiple components or multiple pieces of the system that are needed to achieve those requirements. Every system operates within an environment that influences the system and its operation. And we need to take that into account when we develop our system and our security controls. Authorization boundaries are important, and we'll talk about them in their own module a little bit later, but we have a high overview here. The authorization boundary defines the system for the RMF execution to facilitate the risk management and accountability. The system may be supported by one or more enabling systems that provide support during the system development lifecycle, or SDLC. Enabling systems are not contained within the authorization boundary of the system and do not necessarily exist in the system's environment of operation. Although they exist outside the boundary, they provide support. The term authorization boundary and system boundary are often used interchangeably, and we will use them interchangeably throughout this course. Important to understand inherited controls. We've already talked about those earlier in some earlier modules, but an enabling system may provide common, also referred to as inherited controls, for the system. Other systems are also outside of the authorization boundary and may be the beneficiaries of services provided by the system, or may simply have some general interaction. So our system boundary will define our system. We're going to have some inherited controls that are provided by systems outside of our boundary, and we're also going to have interaction with systems that are outside of our boundaries. So we'll worry about securing the system within our authorization boundary, but we'll also interact with other systems outside of that boundary that provide services or controls, but they're outside the scope of what we are going to implement. Certain parts of the environment of operation may be included in the authorization boundary, which is determined to be in scope for the authorization, while other parts may be excluded. If the facility provides physical and environmental protection as common controls to be inherited by the system, the environment of the operation is out of scope for the system. It is not included in the authorization boundary of the system. In this example, maybe we have our system in a data center, and that data center provides things like cooling and humidity protection and fire prevention and physical security. In those cases, we won't worry about those controls if they're already covered by the common control set that's being provided by the data center. Those controls will be considered to be out of bounds for our authorization. So in closing, this topic covered the following items: definition of an information system, security engineering, system elements, authorization boundary, inherited controls, and inclusion and exclusion in the boundary. If any of these things don't sound familiar, please go back and watch them again, and we'll see you in the next module.